Welcome, everyone. Welcome back to another episode of the LlamaIndex webinar series. We've got a very packed webinar today, and we're excited to talk about fine-tuning and RAG, both of which are very relevant topics, and especially interesting to see how they can be combined together, both on the embedding side as well as on the LLM side. I think we'll go through the agenda. The first bit is that we'll just super happy to feature Tenzin and Ali on their winning hackathon project, just as a cool showcase demo from the community for the first like 7 minutes or so. And so they had a winning hackathon project at the Augment hackathon a few weeks ago. And then we'll dive into the main aspects of fine-tuning and RAG. Super excited to bring on Jo from Vespa as well as Shishir from Berkeley. Jo will present a little bit on using LLMs for synthetic queries. Shishir will talk a little bit about fine-tuning LLMs with the Gorilla model. And then we'll talk a little bit about these topics in the panel discussion between all three of us. So should be a lot of really interesting content, and super excited to get started. So without further ado, maybe in the first few minutes, Ali and Tenzin, do you want to give a quick presentation about your project?
Yeah, of course. I will share my screen real fast. Okay, cool. You guys can see my screen? All right. Sweet. All right, Ali, it's all you.
Awesome. Well, hello, everyone. Thank you so much for having us. I'm Ali Aga, and along with my co-founder, Tenzin Rose, we're building Tali AI. Tali is an AI assistant that is focused on developer support. Recently, we were lucky enough to get invited to the Augment hackathon in Paris, where we won the LlamaIndex bounty. During the hackathon, we leveraged Llama's React agent framework to create a process that is aimed at deflecting customer support tickets. So why customer support? One of the biggest difficulties for any organization is providing customer support. And it's difficult because as your product becomes more successful, there needs to be more support, and your support needs are going to grow in a linear fashion. This obviously is going to be a huge cost to your project, and any tool that can help mitigate the need for human intervention is going to be really helpful.
Yeah, so our goal going into the hackathon was trying to build something that can mimic how a human support agent would solve a problem coming in. And so when you think through it, typically kind of a query comes in, and they have a set of tools at their disposal, such as be able to query the knowledge base, look over questions that have already been asked around the same topic before, maybe doing a web search. And then finally escalating it up to an appropriate person if they can't answer it. And so for the actual hackathon itself, we used LlamaIndex kind of throughout the whole workflow, from Llama Hub, ingesting kind of Discord conversations and embedding those within Deep Lake and using kind of the Deep Lake integration there, and then using kind of Query Engine for our RAG process to actually kind of generate the output. And then of course, the agent workflow with React, which was actually super straightforward and easy to get up and running. So just to give an example of the workflow of what would happen for the actual agent itself, the first request coming in, and we had this over email, would go through a RAG workflow where it would retrieve from the docs. And so that was kind of a two-step process. If it could answer the question, then it would open up a Zendesk ticket and basically close out the ticket and say, yep, this can answer the question. If not, then it would go through another loop in the agent workflow and pull in a tool that might be able to help it answer its problem. And so from there, the idea is we wanted it to retrieve information and fill in the gaps of its knowledge to the point where it can have a fully formed answer, and once it's ready to go, it can answer the question. If it couldn't, then it would assign it to a human via Zendesk. And so we'll show you a quick demo of just how this actually looked.
So for demo purposes, we picked this query because things are going to go slightly different here. It's going to do an initial document retrieval, It's going to try and come up with the answer, and it's going to evaluate that answer. Unfortunately, it's not going to be able to get an adequate solution on the first go around through document retrieval, so it's going to have to use its agent ability and use its different tool sets to answer the question, and we'll see that on screen shortly.
And coming back to that kind of earlier thought, as to how a person might solve it, if you can't answer it with your existing knowledge, you might go and ask somebody internally. So that's where we have kind of the Discord tool. And you can see here, it's now kind of relying on its tools. And another tool we have is kind of a web search. So as a human, you don't have an answer to a question, so you're going to go on Google and try to answer it. And so unfortunately, it wasn't able to answer, but at least we know that. And now this is escalated up to a human, and so the next person in the support queue can pick up the ticket.
And so some learnings we got out of it. One is that our jobs are safe for now. Our human jobs are safe for now. The technology is not quite at the point where it can, be fully autonomous and just free flow, get to a solution. But I think that the biggest learning was limiting the scope of agents for what they can do, and limiting the scope of tools for what they can do. Kind of like a neural net, like each little node along the way should be pretty simple in what it does, but kind of the collection of all these tools and nodes together creates these emergent properties where it can start to solve complex problems. And so that's kind of the learning what we're going to take into how we build out our next iteration of agents. And so yeah, Ali, is there anything else you'd want to add there? You're on mute.
Sorry about that. Yeah, so I was going to say, I think one of the learnings that we took from this is for the agent process to be truly effective, insights gleaned from one tool need to influence and inform how subsequent tools are employed. And I think that's currently lacking. So I think that's what we'd want to focus on in the next iteration of this.
And our kind of path moving forward is take the learnings from this. We already have kind of a linear RAG workflow product out in market. But what we want to do is build support agents that are actually useful for companies, not just cool over demos. And so that's kind of our life mission over however long it takes. If you guys are interested in learning more about what we're doing or just want to have a quick chat, we're always open. And here is how you can find us. We do really appreciate kind of everything you guys are doing at LlamaIndex, and super excited for the rest of this webinar. And yeah, if you want to chat, we're always around.
Great.
Thanks, guys.
Thanks, Tenzin and Ollie, for an amazing presentation. And next up is Jo from Vespa. I believe you have a few slides on LLM synthetic queries and fine-tuning.
Hey, Jerry. Thank you for having me. I'll share my screen. See. Oh. Yeah, it seems like I actually have to quit and reopen Zoom because I didn't have I just installed it. So I'll probably, the question is if I'm able to rejoin.
No worries. How about this? If you want to try rejoining, Shishir, I don't know if you have your slides ready. Maybe you could go first. We could swap the order. Sweet. Okay. Shishir, do you want to go first?
Sounds good, yeah. Let me share my screen. Great. Okay. Is my screen visible?
Yep.
Okay, perfect. Well, firstly, thank you for having me here. For context, I got to know Jerry recently, and Jerry and Simon, and they've been great. Just even brainstorm and get ideas in the brief discussions we have, given how busy they are. So, okay, today I'll be talking about Gorilla, where we're trying to teach LLMs how do you connect it with the API network. And given the topic of today's webinar, I'll try to focus also a little bit on the retriever versus RAG and what our thoughts are over there. So this is a joint effort between Berkeley and Microsoft Research, and it's very academic, and everything we do is in the open source. So at a very high level, the idea behind Gorilla is that, today you have one too many LLMs, And fundamentally, as a user, you are responsible for interacting with the LLM, getting a prompt and response. You can do this over multiple rounds or zero shot, like in the example here. But it's up to you to now go and deploy the information that you get and perform some action on the world to bring about effects into the world, right? And then you get some response from the world. What we envision is a slightly different, which is, can you put the human to the left side? So here, you're only going to talk to an LLM, and the LLM is actually going to introduce effects into the world. This could be just reading the current state, or actually going ahead and putting an effect into the world, getting the response, and then getting the response back to the user. Now, this is a little too abstract. So let's ground this with an example, right? So an example in this scenario would be something that's very topical to all of us, where we go and say, hey, can I get an 800 GPU in East US? And there are ways you can do this today, the CLI through the browser, CR, local Kubernetes cluster, or even going through APIs from your command line. The hope is that we actually talk to an LLM, in this case, Gorilla. And Gorilla can go and then figure out, hey, you asked for 800 GPU in East US. Do you have quota for that? Are you is there any capacity to do that? And if so, I'm going to try. If it fails, try again, and then give you the GPU in East US or an SSH that you can log into. So this is the vision. And to do this, the core idea here is that an LLM is a tool, and then tools need to talk to each other to be more effective. And in computer science, the way tools talk to each other is through API calls. And so with Gorilla, what we're trying to do is train an LLM to actually invoke API calls, right? And so that way you can actually go ahead, read the state of the current world, and also introduce some effects into that. So to begin with, we have a bunch of APIs that we support, but we also have an API zoo where you can contribute your own APIs, so on and so forth. So this is like a high level vision of where we are with the Gorilla project, which is a user comes in with a query. Can you now take this query and then perform some action in the world and then give the response back to the user? And to interact with the world, we're going to use APIs. Okay, so that's fine. Let's step a little into the key question here, right? So the big question is, how do you mix fine-tuning and retrieval? And I think Jerry is also going to bring this up later on in the panel discussion. And what we wish was true is the following, right? And this is in some sense the wisdom of the crowd, is that, fine-tuning is to augment the behavior of the model, while retrieval is to introduce new knowledge to the model. So when we started off, this was roughly where all of our heads were at. But I think increasingly what we're observing is that fine-tuning is also remarkably effective at both behavior and at knowledge. Except this is extremely brittle, right? How often do you fine-tune an LLM? Maybe once every 6 months, once every year. How often does the current world change? On the daily, right? If not weekly. So the solution that and the other key observation is that retrievers are actually inaccurate. And when I say retriever here, I'm not referring to a single retriever, but the whole class of retrievers, right? And this has been pretty well studied in the recommendation and ranking system. Today, if you go to Google and do a search, you're fundamentally trying to retrieve documents based on the inverted index that you built to show to you what's relevant, right? So retrievers are inaccurate. And by inaccurate, I mean, if you take something like recall at k, say k equals 3, how well does a retriever perform? And state-of-the-art retrievers get you somewhere around 70 or 80%, which is good. But if you think of it the other way, you're wrong 1/3 of the time. As in 1/3 of the time in your top 3 recall at k, you don't have the right answer. Of course, this is all conditioned on your underlying distribution, so on and so forth. But this is like a rough rule of thumb, especially when you go to billion scale. So the solution that we propose is something called retrieval-aware training, right? So this is pretty simple. The retrieval-aware training idea is that you teach the model to either use or ignore the retrieved context, right? So if there's one thing you want to take away from this talk, it's this, which is that retrievers are inaccurate, but you're going to use them because you need to augment your model with new information. Why not also teach the model that, hey, I'm going to give you some additional piece of context to help you answer the question. Every time you're trying to answer the question, make this one bit high-level decision. Is this correct? Or do you think it's incorrect? And it's usually a confidence interval that you're looking for. So I'll give another example, but the way you're going to train this is by introducing both correct and incorrect results during instruction fine-tuning. And by doing this, you're making sure that your model is robust to low-quality retrieval, right? So, if the debate is fine-tune versus RAG, and there's a lot of people are saying, hey, don't do this, it's not even, use one or the other based on relevance. We're not even saying that. We're saying, actually use one that's augmented with the other, right? And so as a quick example, suppose you say, hey, I'm an engineer at Uber, and I want to identify pedestrians, cars, etc. And suppose this is the RAG context that you got, which is used the object detection framework from PyTorch as an API call. The first thing that you want to do is you want to ask a question, is this relevant? In this case, yes, you can use an object detector to identify if there's any, to identify pedestrians. So you're going to answer to the prompt. In the scenario where this is incorrect, right? So for example, if they said, hey, why don't you use if your retriever, your RAG system told you, use a translation API in this case, PyTorch FairSec, then you're like, wait a sec. The person wants to classify pedestrians and cars, but you're telling me to use a fair sequence API? That doesn't sound right. So then you can be like, hey, I'm going to discard this and actually use information that I have from my pre-training or even in my fine-tuning to then go ahead and answer the question, right? So use RAG and teach the model to implicitly, this is not explicit, the model is not going to tell you, oh, this is correct or wrong, but implicitly teach it a distribution of what I think is relevant, what I think is not relevant, and then help answer the question. So this is at a high level what retrieval aware training is. And finally, this is what we deploy in Gorilla, and we have deployed Gorilla into the world, very similar to some of the other projects. It's an open source project, so feel free to check it out, and I'm happy to give time back to Jerry.
Awesome. Thanks for the presentation. Lots of stuff to talk about in the panel as well. And Joe, do you think your screen share is working?
Let's hope. Let's see.
Sweet.
Yeah, let's see. Yeah, you can see my screen, I hope. Yeah, so I'll quickly talk about boosting retrieval and using large language models to generate synthetic questions. So I'm Jo Bergum, and I work on the Vespa team, which is an open source platform for everything retrieval. Open source, Apache 2.0 license. You can search, filter, embedding, tensor search, use at scale, Yahoo, Spotify. We just crossed 11 million downloads. Yeah, so that's quickly about Vespa. In the RAG context or in the retrieval or any search engine, your basic task is that you have a set of documents, you have a query, a user intent expressed as a query. It might not be a user, it could actually be generated by a Gorilla or an agent framework. And then you have a ranking model that produces a ranking or an ordering of these documents, right? So, and then you can basically look at those results and the order of those results, and you can label them either by using annotators, or you can use quick feedback from users and so forth, or nowadays you can even use a large language model to judge how well is that ranking model working. And then we could use metrics like NGCG, recall, and so forth. So just a high level overview of retrieval and ranking. And typically when we train models like ranking models, they might be embedding models, you use a lot of examples of queries and relevant documents and potentially also irrelevant documents, and you train a ranking model, for example, on MS Marco, which is a large data set of annotated data set with queries and relevant documents. And then you try to, if you try to use this model in a different domain, we call that a zero-shot ranking, meaning you're taking a ranking model that has been trained in something else, and then you're applying it to your domain. And this is where fine-tuning for retrieval for your domain comes in. So either you start up fresh, ask people to annotate data for you, or you maybe ask nowadays a large language model to annotate data, or you use interaction data from users, right? And our aim is then to optimize the ranking, the ordering of these results so that we have relevant results. And I think this touches on like in the RAG context as well, is that you try to optimize the retrieve context for the RAG, for the generation. Yeah, and last year a lot of researchers starting to use large language models actually to generate data so that we can train ranking models and to adapt the ranking models to specific domains. And because most organizations, I mean, if you start out fresh, you don't have any interaction data that you can train on. And by interaction data, I mean clicks and feedback from users, or you don't have money to buy human annotators. So a promising direction is to actually generate synthetic training data using large language models. And I'll describe a rough overview of this process. So you have a set of documents or a collection or a chunk of text or passages, paragraph, or basically information that you want to search over. And then you can iterate over those documents, and for each of them, you give that into the large language model prompt, and you have a prompt basically saying, hey, you are an expert, a relevance expert, and you can suggest some relevant queries for this article. And then you get a set of synthetic queries for these documents, and we can semi-annotate these as labeled data, right? And this labeled data, we can use that data to adapt our ranking model. So here's an example that I used in the earlier talk. There's an article, and it's generating a set of suggestions. And using this, we have labeled data that we can use to adapt our ranking model, be it if we are using an embedding model, or if we're using a cross-encoder, or different types of retrieval and ranking models that you can have in a pipeline. And then you can evaluate that ranking model in your domain, and then ship it, if it works, ship it to production. And I'll give a concrete example. Because Vespa, the Vespa's become quite popular. We went from 2 million downloads to 8 million downloads in about 3 months, and we got a lot of questions. So we had to try to also build a RAG pipeline over our documentation search. A document page in our documentation, where there's a title, there's some content, and the question by a large language model. So it has generated this, what is the Vespa access log format? How can custom key value pairs be added? And these, we can actually use them also in the search adjacents. So when people are searching in this system and typing in, we can actually use those generated queries and to suggest so that the user actually can explore what's this system able to answer. And here's the experience where you have search for what is the access Vespa log format. The retrieval pipeline brings up the relevant result, and the generative abstract on the top right is generating an abstract. So this is one way to augment the data with these synthetic questions to improve the retriever. And Spotify, and this is used in production, I think, by many companies, that they annotate and generate using synthetic data to help training their dense retrievers. So Spotify is using Vespa for their natural question search, and they did a blog on this year where they also confirmed that they were using this synthetic query generations, because they had trained their encoder on interaction data, and interaction data is typically biased towards the most popular podcasts, right? Those are the ones that are getting interactions. So this is one way to overcome that and to improve retrieval quality. So I personally think it's a very, very promising direction. I'll also just include this slide because when you start adopting and training and adapting, for example, embedding models, if you are using an open source model and you're updating the weights, or you're using OpenAI embeddings and you want to fine tune them or project them, then you have also a versioning problem, some practical issues that you need to take care of. And I did a few blog posts on this, on how to actually use frozen embedding so that you don't have to re-embed everything if you are training and iterate on your embedding model. Yeah, that's actually what I had. Just a few slides.
Amazing. Cool. Thanks for the presentation, Jo. Okay, well, let's get into it. So I think, I figured the panel portion could take like 20, 30 minutes or so, and we've kind of come up with a high-level list of questions to discuss. And maybe a good question to start with is, so both of you have talked about some idea of training a model, whether it's the retrieval model or the language model. And both of these are obviously components of a RAG pipeline. And so curious at a high level, like what is the current high level relationship between fine-tuning, training, and RAG? Where does it operate within pipelines today? How complementary are they? And then also, what's your prediction maybe like 2 to 5 years from now, like whether or not they'll overlap more and start replacing each other, and let's go from there. And maybe we could start with Jo.
Yeah, okay, so coming from a search background, where we've been building these multi-phase retrieval and ranking pipelines, like independent of generative models and RAG pipelines. Typically, you want to train the re-rankers on top of the distribution of the retrievers. So you cannot really change the retriever without also retraining the re-ranker. I think this slightly changes when you're using like frozen foundation models like OpenAI, ChatGPT, those type of models, because they are frozen, right? So in those cases, I think that you can update the retrieval quality, fine-tune your embeddings, because if there's something that we know, and that is that these embedding models might not necessarily beat like traditional BM25 straight out of the box for any type of use case that you have, right? So they might, you might want to look at fine-tuning. And I think one promising approach for fine-tuning to generate that data is to use actually large language models also to aid with generating that label data. I mean, and the field is moving so fast, and we've seen like the whole information retrieval field as well has been affected by large language models. All the papers are about large language models. So it's very hard to see where we're going in 3 to 5 years. Maybe all the fine-tuning won't be necessarily. Maybe you will get to 95% without fine-tuning. I don't know. Yeah.
I'm sure. Any thoughts?
Yeah, no, I think I agree with Jo in that you would have to, a classic BM25 may not be applicable for you. So, there's always some efforts going on into training the re-ranker itself. And, probably not just the L2 re-ranker, but even like, how do you get your top K documents? So the entire pipeline today is anyway in the recommendation ranking systems being trained. I think the other question of, what about fine-tuning the LLM itself? I think it's also quite relevant. And if not anything, at the very least, to make it more, some people prefer, it's shown that for all these chatbots, just the, does it give long answers or short answers affects the quality of it. A lot of people like long answers, a lot of people like short answers, and it's personalized, right? So yeah, even outside of information, I feel like just for the output formatting, people do fine-tuning. So I think, Jay, to your question, both in the short term and in the long term, both RAG and fine-tuning of the LLMs themselves is also, I think, quite complementary, mostly because you're going to always use RAG to, come up with those last few percentage points, especially as freshness of data becomes more and more critical for the applications that you pick. But at the same time, you're going to use fine-tuning as a way to add more knowledge, bake that in, and also teach it to answer to your given style and formatting, etc.
So let's dive into that a little bit more. This is a nice segue into, let's talk about LLM fine-tuning, especially with, for instance, like OpenAI's fine-tuning endpoints, as well as the rise of fine-tuning open source models. What are the main use cases that we're seeing today with fine-tuning? And I know, Shishir, you just presented like kind of your techniques on like retrieval augmented like fine-tuning, but like what are typically the use cases that people see? Is it like distillation, style transfer, like baking in knowledge? And then, but curious to hear your thoughts.
Yeah, I think a lot of it is mostly baking in the knowledge, right? Distillation was cool for open leaderboards kind of style, where you want to like benchmark how good is your model compared to the larger models. But in a lot of scenarios, it's less because if you could use a bigger model almost at scale, that at price points you can't really compete. So a lot of the times people do fine-tuning mostly to bake in the knowledge for their specific use cases. At least the way people are using Gorilla today is, now I want to do a quick onboarding, or I want to serve my own set of APIs from one team within a company to another team, etc. So, and even outside of this, I think the way, at least we see most people use fine-tuning in academia and in enterprises, is to bake in information, make it more, make the answers more along the lines of what downstream task you have. Like if your downstream task expects a certain format, like if it expects some interpretability for the users, then give that. If it expects some translation, then give it to an intermediate representation and then hand it off to the downstream task. So yeah, knowledge and supporting the workflow are the two reasons why I think we see most people do fine tuning.
So when you say baking in knowledge, do you see this kind of similar to, and you want to pair this with like a retrieval system? Is it that when a user asks a question, maybe you first want to see if the model itself knows the answer, but like, or you just like always add this retrieval mechanism there so that in the event it doesn't know the answer, you can, look up information in the provided context. How do you like, I mean, it's related to your slides too, but how do you see that interaction?
Yeah, I think, and despite this should come as a surprise to nobody, but most people like the zero shot setting, right? Because it's so clean to understand like what's going on. And when you introduce a retriever, now this is like more of an enterprise use case. Okay, there's someone who's keeping the retriever fresh because you can have the best retriever, but if it's not kept fresh, then I mean, you're not helping the cause much. So yeah, I feel like a lot of people for the initial use cases do fine tuning, but the moment you want to put this in production, where you're like, hey, look, if someone asks for an answer, like the freshness of the data becomes critical, then people tend to augment that with the retriever. But in terms of, can I bake in all the knowledge that I want to bake in just by using fine tuning without retriever? And I think the answer is, even for like something like a 13 billion model, the answer seems to be yes. Like we haven't really hit the bar where we say, we can't bake in all the knowledge, it's getting confused, maybe we need a retriever. I don't think that, yeah.
Interesting. Gotcha. And Jo, did you have thoughts you wanted to add on that?
Well, I think in any fine tuning, if it's for retrieval or fine tuning the generative model, I think the bottleneck is always going to be the actual labeled data, right? Who's going to produce that labeled data? So I think that's a challenge for most organizations. I mean, mature organizations, they will have that, but still generative AI is relatively new. And like, how well do they respond to? So I think for most organizations, fine tuning is especially on the case. I have to. That's my thoughts on it. I mean, open source maybe changes this a little bit because if you're using commercial vendors, you have to pay more for the token cost and so forth. So, and what's then the quality? And how many examples do you need to steer it in the direction that you want? So yeah.
Right. So on that topic, and maybe back to you, Shishir, like on the topic of like LLM fine-tuning, how do you think about like data preparation? Is it possible to do this in a synthetic automated fashion? Kind of especially given the paper that you had, like, do you actually need human labels, or just given a piece of unstructured text, you can just like bake in that knowledge automatically through fine-tuning a model?
Yeah, and this is a great question. And I think the way I think about this is short answer, no, you don't need human labelers. In fact, a lot of the labeling companies, when we spoke to, they're like, yeah, in the backend, we use GPT-4 or Claude. So even the labelers whom you would outsource to us, if it's not offshore, then it's mostly to LLMs. But I think with techniques like self-instruct and even otherwise, like if you look at the way, right, you're basically doing perplexity loss minimization over the next token prediction. So you could use unstructured data. So for a lot of the times, just using this unstructured data or using like a general purpose LLM, and this doesn't have to be the state of the art, but even like a Llama 270B, to take your information and come up the reverse of that, P of Y given X, where you're trying to like look at the data that you have and generate labels for that. I think a lot of people use LLMs, and this is noisy for sure, right? And humans are going to be way more precise no matter whom you pick, but I feel like with LLMs, they have enough context and there's enough knowledge about the language itself that it's actually quite robust to noise. Like you can go very far to the extent you can go for in production deployment just by looking at your, just looking at the data and your self-instruct labels. And this is not even throwing in RLHF or any of the other techniques that people might use.
Interesting. Jo, is there thoughts that you want to add on along these lines?
No, I don't have any.
Sweet, no worries. And then kind of transitioning now to the kind of fine-tuning the retrieval side. And the data question I think is always going to be very interesting, and I'd love to chat about that more. But on the kind of like retrieval and embedding fine-tuning, Even like right now, and I'm curious, Joe, like in your experience, like how much this is actually boost like retrieval performance when you kind of like do the synthetic query generation and fine tuning optimization, like what percentage points does actually move the needle? And like, would you actually recommend this as one of the main techniques to, if you're trying to build like RAG, you should always fine tune the retriever?
Right. Yeah, that's a great question. I think in the papers where researchers have explored these techniques, so there's a benchmark called BEER, which is a collection of multiple information retrieval data sets. And when they use a large language model so that they train a new model in a zero-shot setting using large language model to generate those synthetic questions, we're seeing lifts from 10% to 20% in NGCG on those domain, and also top of the leaderboard for BEER. So it definitely works, and especially if you compare it with dense retrieval for RAG for very long questions. Like if people are typing up like outside of the traditional keyword search, like what's the president of the USA? If you're starting to have like longer, more conversational, it's really out of domain compared to what those embedding models that are off the shelf have been trained on. So you're definitely in a kind of new domain setting. But there are alternatives like hybrid search that we talk about a lot in Vespa, where you combine keyword search with embedding-based retrieval. And we know also that embedding-based retrieval is basically compressing the text into one vector representation, which doesn't generalize that well because you're basically doing representation learning. So there's definitely things to, and I see this really promising because it's always been a problem with, getting the data for training ranking models. And that's why I'm so excited about this technique, is that this is a way that you relatively cheaply can generate training data. And that data is not biased, right? Because if you're starting fresh with BM25 or popularity-based ranking, it's going to be biased towards that. And then your users are interacting with that, and then you are training a ranking model on that. You're basically just doing an incremental adjustment of the result, right? Because it's only the top results that are getting interactions. So that's why, like Spotify is also using this to improve the retrievability so that you have less biases in the system. Yeah.
That's a great point. Actually, maybe in like 10 to 15 seconds, I think I roughly have context on this, but for listeners, could you maybe just like elaborate a bit more on how that bias exists for recommender systems?
Right. So typically, recommender system will have, if you start off fresh with a recommender system, you have like a cold start, right? So what do you do then? Then you show the users the popular items, right? The most popular items. You have some notion of popularity. So you show them that. And then the user starts interacting with that, watching that but there's a bias because there was a selection of what's been shown there, right? So when you interact with that, you're basically just learning your preferences from the top most popular items. You're just re-ranking and optimizing that. You won't know that there's a super relevant series that is just super relevant for you because it hasn't gained that initial popularity, right? So this is a huge problem in any search and recommender system, and I really love that large language models can help us with this, because that's what I've shown in my diagram, is that you're basically iterating over all the documents in your collection. So they pretty much all of them get a fair chance to be in the training data and to be retrieved.
Super interesting.
Yeah. And the paper from Spotify that I linked to, I'll share my slides on Twitter later on. They actually demonstrate that it does improve retrievability. So it does reduce the biases. Yeah.
A quick follow-up question to what the technique you're describing. Are there any issues with stuff like mode collapse, or like if you actually fine-tune this retriever, it actually ends up being less generalizable because you overfit it to this data set?
Yeah, I think definitely. I think bioencoder embedding models are difficult to train, and we had a few students that tried this this summer, and they were struggling with certain domains, and yeah, so definitely, I mean, bioencoders with contrastive learning, it's not as trivial as training re-rankers that just using a traditional classification loss. Much harder to train. So definitely, yeah. But sentence transformers, I think your example in LlamaIndex uses that. We also use that. We had a blog post on that. So if you want to train your own bioencoder or cross encoder, it's a great library to be used. And they have multiple different loss functions. Yeah.
Sweet. And then maybe that generalizes into the broader question, and this is a question for both Jo and Shishir. Yeah, what are the kind of biggest challenges in embedding fine-tuning, LLM fine-tuning today? You know, like is it a magic bullet? Like what are the things that people need to consider, like mode collapse, cost, latency, performance, like evaluation, all these things?
Yeah, I'll start on the embedding side. One huge issue is that most technologies are not that mature when it comes to embedding management, because if you start to fine-tune embedding models, right, and if you don't have a separate query tower and the document tower, then you have to re-embed all the data that you are searching, right? Just to do an A/B test, you have to re-embed that, right? And that means you have to run inference again, and you have to pay the cost of that. Then you might need to manage that in the various vector solutions that people are using. So that's one thing, you know, is really a challenge. And I think there are many organizations that are dealing with large data volumes. They are moving towards frozen document side embedding. So you're basically freezing the document side embedding, and then you are adjusting the query tower so that you don't have to deal with this, because then A/B testing of a new model is simply just changing the query tower. You don't have to re-embed all your documents. So that's one concrete challenge with fine-tuning, and of course the data, you know, generating the data and so forth. But I think we touched on that already.
And is the challenge there actually more like scale, cost, speed, that type of thing?
Scale and cost, yeah.
Gotcha. Makes sense. And Shishir, passing it to you.
Yeah, I think so. There are two parts to this, right? One is that as these models are becoming multimodal, how do you like try to think about all the different data modalities, especially when the data gets larger? I know, Jerry, you guys came up with a nice algorithm and a blog very recently on, you know, how do you compare with the smaller chunks and then pick which larger chunks. So that's a step in the right direction, right? So yeah, when you have multimodal data, like, you know, people have a lot of enterprises have like tables worth of data, and it's not clear if, you know, is the tokenization scheme we have right now the best, even for if you have tabular data. But on the other side, I feel like we don't have enough scaling laws for fine-tuning, right? How much data is enough? Okay, you know, you have a big pipeline. This includes your RAG system. This includes your LLM. What do you use to fine-tune the LLM? What do you use to fine-tune the RAG? And, you know, how does data and compute scale? And, you know, at what point do you know you've got the most bang out of the buck for RAG, and what point do you focus on the LLM, and vice versa? So I feel like, especially if you're starting off as a practitioner and you want to ask how much data is enough, that's a question, you know, we struggle with. Okay, is this good enough? Are we generalizing enough? Are we overfitting? I feel like there's a lot of unknowns on what's the scaling laws for fine-tuning.
So maybe like, you know, because for members of the audience, like maybe a lot of people might not have as deep of like ML training backgrounds. Like, are there any practical concrete tips or just like even rules of thumb you would give just if someone wants to start fine tuning, like one, should they start doing it? And then two, like what like basic principles should they follow?
Yeah, for sure. And I think today, like there's so much resources available that if you can, you're better off fine tuning. The only reason you wouldn't do is if you cannot have the infrastructure to serve it, right? Because serving is batch size one inference, at least initially when your queue is not big enough that you can really patch it. So it can get really expensive. For fine tuning, I would say for a model of size 7 billion, which seems to be a sweet spot that you can run on most commercial and server grade GPUs, roughly around order of tens of thousands instruction API pairs seem to be good enough data. So which means that you have 10,000 data points, maybe of context length 2048 or 4096. These seem to be reasonable context lengths where you can get meaningful information out from the LLM. So that's a good rule of thumb. If you're generating the self-instruct data set where you have your data, how do I label it? Generating about 10 instruct API pairs per data point that you have also seems to be a good rule of thumb. Keep the learning rate low, and and unlike fine tuning where you tend to be a single epoch or 1.4 or 1.5 epochs, I think for fine tuning what people have observed is multiple epochs actually helps, and you still see a smooth learning curve, not just step function learning curves, even when you do multiple epochs.
Sweet.
Yeah, so these are probably like.
Yeah, no, that's awesome. These are very useful tips. I think maybe doing like a really quick detour, maybe for like a few minutes. I've realized just at a very high level, there might be like different aspects of fine tuning. I think when we talk about fine tuning, we basically talk about it in this like very big bucket, and I'm kind of curious like to get your thoughts as to what are the maybe slightly different categories of fine tuning and how should people really think about it today, both on the LLM and maybe embedding side as well. There's like full model fine tuning. There's like, you train an adapter on top of some like frozen layer. Like, what are the different types of fine tuning, and how should we think about and use them?
Yeah, I can talk briefly on the embedding side. So you can use. I talk about frozen embedding side. So the LoRa equivalent of that is to add a linear layer on top of that to project them, so that you can actually use, for instance, OpenAI embedding as your foundational embedding model, and then you can add layers on top of that. So the initial representation of the text is frozen. So that's one way. And I think I personally really love that approach, is because you then, as I said, you don't have to reprocess your embedding, which is at some scale, it becomes costly, and you need to manage that and change versions and so forth. So on the embedding side, yeah, definitely. But I think also then fine tuning is on embedding models, there's more there around, how much do you actually put into one embedding, and that goes into the chunking and multi-vector representations. And I think the RAG community has been focusing on like first everything packed into a cosine similarity. Now we see more advanced techniques, and I think that's a promising direction, and people are discovering more ways. And so I think that's also an alternative from trying to just optimize your embedding model. It might be a dead end if you are chunking too long text into one representation. Yeah.
Got it. And sorry, wait, just to clarify there, when you say maybe one kind of implication of like training this linear layer adapter on top of any like black box embedding model is like, the linear layer is fast to compute, right? So it's basically just a matrix multiplication. And so basically you're kind of accepting the fact that you just do an extra matrix multiplication so that you don't have to like re-embed the kind of like core documents.
Correct.
Got it. Cool. Sure. Any thoughts on the LLM side?
Yeah, I think on the LLM side, Jerry, you're right. And I feel like the way people are starting off is, look, if you have resources, then you would do full end-to-end fine-tuning, right? Mostly because you get real good performance, not just in baking in more information/knowledge, but also making the LLM more aligned to your response. So I think full end-to-end fine-tuning is what most people are going for, especially when you deploy it, be it for hobby or for production. And QLoRa tends to be, or even just LoRa in general. Well, first, I think a lot of techniques that people tried in the paper that was like 0.1%. I don't think people do that anymore. It's now they do like 10% of your weight. So basically you're trying to train among 10% of your weights, not the whole set of weights. You're getting some memory benefits, so it's faster and so on and so forth. But even then, I feel like these tend to work very well for vision models, like I'll say the diffusion line of work that's going on. But for languages, people have tried to, and for interesting insights and outputs, but I still feel like there's a long way to go to match the performance of full end-to-end fine-tuning for languages, at least. I think for vision it's fine. For vision, LoRa tends to do pretty well.
Oh, okay, that's interesting. Okay, maybe just to close out the webinar with a last kind of big question. This relates to this idea that as a AI engineer in this new world of like LLM development, a lot of people with like maybe more of a data science ML background are pretty familiar with the idea of like preparing a data set, training, evaluation, test data set, and then also like training a model. You kind of learn that in the intro ML course. But if you're maybe like coming from like a more standard software engineering background, this idea of like fine tuning a model might seem a little daunting. What are kind of your recommendations of like both like tools as well as like initial things to start with if you are kind of just entering this world and trying to understand how this could help like impact your LLM application.
I think it makes sense to evaluate RAG pipelines on both the retriever stage and the generative stage, right? So has the retriever actually retrieved relevant context, right? And then to go about doing that, basically generate, with your knowledge about how users are going to use the system, generate questions like make a few instructions, a few shots to the language models, and it can generate you 1,000 questions, and then you basically go through them, and then you can eyeball the result, right? As a stupid way, right? But still, doing that, and then you're creating your old kind of golden test set. You might find that it becomes like a whack-a-mole. If you change this query, it gets better, but this other, but that's the case with all kinds of retrieval methods. But I think that's the only way you can and then even today you can actually ask the large language models to evaluate the ranking results, right, with pretty good accuracy. And so I think starting out small. I don't know that many tools around this, but maybe Shishir can talk about like on the gorilla on the generative side to evaluate the output of the final component in the RAG pipeline.
Yeah, no, I think this is a question we ask ourselves a lot, especially when we try to teach undergrads. And I think the consensus seems to be, in your undergrad, when you learn machine learning or data science, you start off from something very small and you slowly build up. Right? You think of linear regressors, logistic, and then expectation maximization, so on and so forth. In LLM, the field is so new, so the benefit is that there's not much for you to catch up on. So it's a good time to get started if you're interested in fine-tuning, evaluating LLMs, etc. And also at the second, not a whole bunch of clarity exists because the field is so new, right? So the way you want to dive head first is take anything, like take an LLM that you like and just poke around with it, right? So that would give you more insights than say starting or building up a ramp, so on and so forth. On the side of data, one thing that I would say that's very contrastive compared to what we did historically in classical ML is a lot of the things we did depend on the class. Oh, is this anomaly detection? Oh, is this classification? Oh, is this multi-label? Oh, is this regressor? With LLMs, all of that is in some sense reduced, right? It's all condensed to one token prediction. So in terms of data, think along the lines of what is the amount of information I'm baking into an input prompt, and what is the output that I expect from the LLM, independent of what the task is at hand, right? So obviously there's a lot of generalization going on here, but I would say think more in terms of, okay, how best can I feed in my input all the information that the model needs and expect the result in the output that I need, or train the model to do that, and not worry much about the different classes, etc., which seems to be how we did classical ML. That helps.
Awesome. I think
maybe
just sorry, go ahead.
No, it's a very good point.
Maybe just to close out, we have just 2 quick questions from the audience, and then I just to go through. One is maybe relevant for both embedding and LLM fine tuning. I think DeMarcus asks, how often should you fine tune? Is there like a data threshold that you should kick off like a continuous like training job? Like how often should you do this? That's something I'm curious about, both from the like practical empirical side as well as the research side.
Yeah, I can go. Sorry.
Yeah, just go ahead, please.
Yeah, so I think for LLMs, so it's not about, okay, so look, I said that roughly around order of tens of thousands of data points is the minimum that you would need at least to get meaningful result. But with LLM, the output it's not a 1 or 0, right? Like you're getting some tokens as output that you're trying to then use in your downstream task. So evaluation becomes very critical, especially if you have a pipeline built around it. So while something like never-ending learning or continuous learning for LLMs is very tempting, what happens is, how are you going to do evaluation? So typically what people tend to have is to have like a very clear pipeline. They test it a bunch. And if this works fine, then they push it into deployment. This is hard to do if you're doing continuous learning. So, because how robust is your downstream task? What happens if it's brittle and it breaks? So unlike classical ML, where data was the key, here also evaluation now becomes key. So if you have a continuous evaluation pipeline, fine tune as much as possible. But otherwise, I would say your evaluation is going to bottleneck how much can you fine tune and how often can you fine tune.
Yeah, and
Yeah.
of course cost, right? I don't have anything else to add than that, and the cost of retraining, re-examples. But I agree, evaluation is likely the bottleneck on any fine tuning. Yeah,
makes a lot of sense. And then last question is, what metrics can we use to evaluate LLMs on generation, assuming you hold retrieval fixed? Is it like Rouge, Blue Score? What are your kind of like top metrics? Sure.
Yeah. So so I think that's a good question, and I feel like in terms of on the LLMs, so on the RAG side, I think most there was NDCG, etc. that Joe mentioned, but those are complex metrics that might be hard for people to wrap their heads around. So I think what people tend to do is recall at K seems to be a reasonable. It's also an offline metric. Offline in the sense you don't need live user data like click-through rate, which is an online metric, etc. So recall at K seems to be a good offline metric for retrievals. If you want to benchmark that, that most people can use right off the bat. And for LLMs, I think it's like today what most people really are trying to reduce is hallucination. So I didn't talk much about it, but one thing that we found has been super helpful is to use the abstract syntax tree matching. This is going back to programming languages domain and using that as a metric to ground your output of LLMs to see if there's any hallucination or not. That's critical. In terms of accuracy, I would think you're better off measuring the downstream task for accuracy than individual point-wise LLM, because how do you do that? That seems pretty tricky.
Cool. All right. Well, thanks, guys. Thanks so much for your time, Joe and Shishir. This has been an awesome webinar, and for those of you who will eventually watch the YouTube recording, I'm really sorry about the Zoom cap. I'll get this fixed next time. But this is a very popular. There was a lot of interest in this webinar, and so I'm super excited to get this content out. And so thanks, guys, for your time.
thank you.
Thank you for having us, Sherry.
Fantastic.
Yeah.